Hello guys, welcome to my YouTube channel. In this video, I will tell you how we can implement linear regression using machine learning library called as scikit-learn. Okay. So first of all, in the earlier implementation video, we have just used to implement it from scratch using NumPy just to get hold of the gradient descent algorithm, how it works. Okay. So in this video, we will just make use of the machine learning library, which takes care of all the gradient descent and other algorithms in the backend. Okay. So we do not have to code much when we use machine learning libraries. Okay. So for that, we have to anyway install scikit-learn library. Okay. So you can use from within the Jupyter notebook, you can use like this. You can say pip install scikit-learn. Okay. So once you execute it, this library will be installed. Once it is installed, you can import it using sklearn. Okay. So this is already, it says could not scikit-learn from versions, no matching distributions found. So there may be an issue in the way that I am specifying the library. So hopefully this will work now. So scikit-learn. So see, in order to install the scikit-learn library, you have to execute it like this. So pip install scikit-learn. Since I already have it in my machine, so it says requirement already satisfied. Okay. So warning, you can ignore it. So for the sake of clean notebook, I'll just delete this. Okay. So now that we have installed the machine learning library scikit-learn, we will have to import it. So how we can import it? So I have to read the data and I have to make use of NumPy. Because the data is one dimensional, we have only one feature and one variable. Okay, one target variable. So I'm using NumPy, I'm using pandas. For visualization, I'm using matplotlib. And to import the linear regression model from the library, all I have to do is sklearn from sklearn.linear models. This sklearn will come once you install scikit-learn. Okay, as you have seen in my previous step. Okay. So once you install that, you can import linear regression model like this, sklearn.linear model, import linear regression. Okay. And also from sklearn.metrics, you can import R2 score so that we can measure the performance. So as usual, we will see how we can read the data and go ahead with the implementation. Okay. So here I am reading the data. It says name PD is not defined. Okay, so because I have not yet executed or imported the libraries, it will throw me an error. Now that I have imported the libraries, I can read the data now. Okay, so as usual, we'll see the shape of the data. It says 63 records and 2 columns. So this is the same data set that I am using, which we have used for our implementation from scratch. Okay, so it's a Swedish auto insurance data set. I will provide the link in the description. Okay, so now that we have read it, I'll just check the data using head. So this data set is not having any null values or any pre-processing steps. Okay, we will plainly implement the algorithm from scratch. Okay, so we will quickly see how the data looks like. For that, I will say plt.scatter data of x on the x-axis, and for the y-axis, I will say data of y. So this is how the data looks like for each value of x, the respective value of y. Okay. Now, in our previous implementation video, we had made use of some functions, right? Like calculate R2 score, compute gradient descent, like right, compute hypothesis, etc. So for this purpose, using scikit-learn library, we do not have to code all those stuffs. So what we can do, we can simply say, I'll create a variable LR model is equal to linear regression, right? And I will execute it. Now my model is initialized, right? My linear regression model is initialized. All I have to do is I have to train this model on the data that I have, right? For that, I need to prepare the data x and y, correct? So let's say I'm saying x is equal to data of x dot values. So it will give me a NumPy array, correct? Now if we check the shape, it will say 63. It's a one dimensional, but in order to pass the data set to this ML model, in order to train it, we need it to be a 2 dimensional. So what we will do, we will reshape it. So how? X is equal to x dot, I'll just say reshape length of x comma 1. So this will convert the shape of this x into 63 by 1. So right now it has only 63 rows. In the back end it is not having any columns. But now after reshaping it, we have 63 rows with 1 column. Okay. So this is how you reshape. Now that I have reshaped it, if I check the shape of x, it will say 63 by 1. Okay. So similarly, we will get our y variable ready. Y is equal to data of y. Okay. Dot values. And similarly, we will reshape the y variable. Okay. Y dot reshape length of y comma 1. So now if you check the shape of y, it will be 63 by 1. Okay. Now, in order to train the model that which I have initialized here in this step, LR model, this is a plain model. It has not learned anything, right? So if you check LR model dot, you see there are no coefficient or intercept present at the moment because it has not learned anything. Okay. So what we can do, LR, in order to train this, all we have to do is fit. Fit is a method which will train this particular model using the x and y values that we are going to pass to it. So x is our x, target variable is our y. So once we enter it, done. So now our linear regression model is trained. So you guys see how easy it is with using scikit-learn library. Before using it, without using it, we have to write so much of code. We have to implement gradient descent. We have to take care of the vectorization in order to speed up the process, right? So all that things will be done away with once we start using machine learning libraries. Okay, that is scikit-learn. So now that I have trained my model, let me check the score. So even to calculate the R2 score or mean squared error, you do not have to write any fancy functions. You can just say LR model dot score, right? And this score takes x and y, right? So since we do not have any train or test data separated in this case, I'll just pass the same x and y, okay, to check the score. So you see the R2 score is 0.833. It's not that bad, it's not that great, but yes, we are able to train the model and achieve some decent enough R2 score. Okay. So you guys should have already know that R2 score should be as close as possible to 1, right? So this is not bad, I say. Okay. 0.83 is pretty decent score. Now that we have seen it, you guys would already know, if you guys have seen my video earlier, it learns the parameters, right? There are learnable parameters. Since we have one feature, we will have two learnable parameters, right? Because by default, we will have a feature x0 with all the values initialized to 1, and x1 is what this particular x that we have read in the data set. Okay. So this is how the linear regression performs. So x0 we have, x1 we have. So we have two features now after adding x0. So we will have two learnable parameters. So if you guys remember the linear straight line equation, theta z, y equal to mx plus c. In machine learning, it is y hat. The prediction is equal to theta 0 x0 plus theta 1 x1. Correct. So theta 0 x0 is relevant to c part in the straight line equation. Theta 1 x1, and in this particular case, theta 1 is equal to m with respect to straight line equation, mx, right? M. So now we will see those two coefficients. One is coefficient and one is y-intercept, right? So we'll see that LR model dot, you see, you can see coefficient here, right? So if you just check this variable, it will give some value 3.413, right? And if you check LR model dot intercept and check the value, it will give some value. So what are these values? So this value coefficient, you can treat it as theta 1, right, associated with the actual data, that is x, right? And this intercept is, you can relate it to the variable c, the constant c in the straight line equation, y is equal to mx plus c, right? So this is the y-intercept and that value is 19.99, right? So now we will see how well we are fitting the straight line to this particular data points. Okay. So we will see it in a visualization way. So for that we need our predictions, right? So let's say predictions is equal to LR model. This is our trained model now, right? So after training we have learned the coefficient and the intercept, correct? Since we have trained it, we just have to call predict in order to get the prediction, right? This is so simple, guys. So without using this model, we have to use theta transpose x, right, to get the predictions as well and also the hypothesis, correct? So we can do away with all those stuffs, all those complex mathematical and programmatical stuffs. We can just call predict method and pass x to it, right? Boom. Now we have our predictions in it. So if you check the length of predictions, it will be 63 because we have 63 records and have 63 predictions, correct? Now we will see how our linear regression model is doing with the help of visualization. So for that I'll say plt dot scatter. I want anyway x comma y, right? The initial data sets that we have read, and label, I will label it as actual. It will be a scatter plot like just like this. I'm giving the label as actual because these are our actual values, right? Over which we are training the model and fitting a straight line. So this is our actual, and I will plot a line using plt.plot, and instead of y I will have my predictions here, correct? And I want this line to be of color red. So I'll name color as red and label will be prediction, or let's say, yeah, let's say prediction or predicted, right? Actual and predicted. And I'll just place the actual and predicted labels towards top upper left. Okay, so how I can do that? plt.legend location is equal to upper left. So if I just execute it, you see these blue dots here are our actual data points and this is red line, right? So this particular red line is our fitted straight line on top of this particular given data set. So how did we fit this particular straight line? Using our LR model. And how did we arrive at these coefficients and intercept? Using fit method. So fit method will train this model and it will apply the gradient descent algorithm in the backend and then arrive at these particular thetas or the learnable parameters. So it is called as coefficient and intercept. So making use of that, we are even using predict method in order to predict the values, okay, using the given data set. So this is how you can make use of scikit-learn library to implement a linear regression quickly. Of course, this is not a detailed implementation of linear regression. The data set is pretty simple, okay. So in my future upcoming videos, I will take a data set with multiple variables, okay, and I will come up with complete end-to-end implementation of linear regression. What are the process that we will follow in a regular implementation, okay. So that will include exploratory data analysis, EDA. We will make use of feature selection. We will make use of feature engineering. And finally, we will train the model and then predict it on the test data set. Here in this case, we have not even divided the data set into train and test, right? So we'll see all those stuffs in my future videos. But yeah, this is it for this particular video. If you guys have any questions, please reach out to me in comment section. I'll upload this in my GitHub and provide the link in the description, okay? So till we see in the next video, guys. Happy learning. Bye bye.